Okay students, now there is one more dramatically we can say diagram are representing here the concept of complexity. How can we understand by them? Let's see. There is one person who is asking something with another person again and again and again for the n times here. So one person is again and again are using the same repetition of statements. That means what we are doing here, we are doing here for loop again and again. So we are doing here two for loops, so the complexity has to be recognized as order of n square. Let's see another example. There is one person who is asking the question with individually n number of persons here. First it that person asking the question with the one here, second person, and now so on up to n persons here individually. So the number of operations we are applying here n. That means it is a kind of linear search, because comparisons or operations we are applying here individual elements or individual persons. So the complexity is order of n. Now the third example I am taking here, where the problems are solving in two further parts. This is the problem here. Now we are dividing in two basically parts here. One is the mediator. Now this person is applying here questionnaire with these individual persons here. If he will not get here answer, it would search in the second one or in the mid here. So we are splitting that problem here. So the complexity of this kind of splitting this problem or program, it will include here order of log n, where we are splitting the problems in various halves or various sections. So the complexity would be order of log n. Now let's take some points to improve here efficiency of a program. First of all, keep the code as compact and simple as possible. Compact is a very beautiful word we are using here. That means there must be line of code minimum. Second one is looping construct should be kept to the bare minimum. In any program you must try to use looping construct as possible as minimum, because looping constructs increase the complexity of the program and it increase the efficiency of the program. Third one is recursive operations are more efficient than sequence, as we have discussed this point in recursion chapter also. If we use here recursion or recursive functions, it would be more compatible and it would be more efficient for the program as compared for executing sequential statements again and again. Now the next one is correctness and robustness of the program should be considered first. That means if you use here less number of codes, so it must be correct logically, arithmetically or relationally, whatever you desire any output from that code, and it must be robustness. That means it must be completed and it must be clear to everyone what is going on in the program. Now the next one is case study is most important. We have three cases: best case, worst case or average case. Best case where the complexity is minimum, and average case where the number of operations lies between the best case operations and the worst case. And the worst case where you are using lots of constructs there, lots of operations there, so that is considered as the worst case, where the complexity is so large as compared to the average case and the best case. So before writing any program or any algorithm, you must know about that program's complexity in various three cases. You have to analyze in three cases what would be, because a program we can write in different codes. We can use one loop in a program, or it can be sold. It can be sold, again I'm repeating, it can be sold without any using looping construct in that program, because you can use their recursion. you can use their recursive functions, you can eliminate that loop here, so it would be in best case considered. So that's enough for the chapter here. Now this chapter is completed. Thank you so much.